Okay, so in this video we're going to look at 2.7. This is where we have more than one right-angled triangle and we have to solve the problem. Well, it's not really a problem, it's just more of solving the missing side or the length that we need. So in this case here, we actually want to find what xy is. So xy is right here. That's this length. So it's a good idea to make sure you know what you're looking for. So you can mark it off with a highlighter or a different colored pen for your reference. Okay, so that's eventually what we want to figure out. Now, the key when there's two triangle questions is that you want to, you don't, if you look here at this triangle, you don't have enough information, but you have enough information for this other right angle triangle here. So the idea is to solve for the side that they share. So this is what the two triangles share. So why don't we use triangle WYZ to find this side here that they share, which is to find YW. Okay, so in order to find YW, we're going to use sine. So it's sine Z, and that's YW over YZ. So we have sine of 20 degrees is equal to YW over 8.4. Solving for YW, multiply 8.4 on both sides, and we end up with this. Okay. All right, so now you want to calculate this number, but you don't want to round this number. Okay, so this ends up being 2.8729. So don't round this. You want to be able to keep it in memory or store it because we're going to use it to find xy. So now let's find xy, which is this one. So now we have a number for here, which is 2.87 something. And now we have enough information to figure out that line. This angle, by the way, goes right here. So let's use cosine y equals YW over xy. So cos of 22 degrees is equal to 2.8729 dot dot dot, that's the number we found, over xy. Alright, that's the adjacent over hypotenuse. So xy, now solve for xy, and we end up getting 2.8729 divided by cosine of 22 degrees. And that ends up equaling 3.0985 dot dot dot. Okay, so all of that, now we have figured out that xy is approximately 3.1 centimeters. Okay, so that's this length right here. From here to here is 3.1 centimeters. Okay. All right, so next we're going to look at the surveyor question. A surveyor is a person that, do you guys know what a surveyor is? A surveyor is a person that stands on the side of the street or stands somewhere and measures how far buildings are from each other, how wide streets are. They use them in construction all the time. You'll see those guys standing in the boulevard and they have these big tripods and these cameras and they look like they're taking pictures of cars going by. What they're doing is they're looking at the elevation and the width and the angles of the streets so that they can determine whether or not they want to, you know, reconstruct, rebuild, make the roads bigger, things like that. So it's a really cool job. So this one here, the surveyor is standing in a building. So this here is a building, and this here is another building. This is a taller building, that's why it's called T. And this is S because that's where the surveyor is standing. He uses a clinometer. Now a clinometer is like a protractor, but you hold it up and there's something that dangles and you can read off the angle of how high up something is, so the angle of elevation and the angle of depression from where they're standing. So they stand here and they measure. Angle of elevation is 31 to the top of the building. Angle of depression to the bottom, to the ground, to the base, is 42. And he is 39 meters up. So this 39 meters, it also corresponds to over here, right? Because this is a horizontal line. So we're going to use this right angle triangle and this right angle triangle to figure out how tall this taller building is. Well, this is 39 from here to here. So we need to figure out this distance right here and then add the two together. But before we can do that, we need to figure out this middle line, which is the line that these two triangles share. So let's do that. Once we have this, we can figure out what this length is right there. So eventually this is what we're going to do. We're going to go BT equals MB plus MT. Okay, so first in order we're going to use this. We're going to use this. So this is opposite according to this angle, and then this is adjacent. So let's use tan. Tan S equals MB over SM. And so that's tan of 42 degrees, and that's 39 over SM. SM is equal to 39 over tan of 42 degrees, and that's equal to 43.3183, I think I mixed up the 3 and the 8. 3138 ... meters. Don't round here. Don't round that number. Okay, so now we're going to solve for MT using tan in this triangle right here. So we're going to solve for MT, and we have this is 43.3138 meters. Okay, so we're using tan again. Tan S equals MT over SM, and then tan of 31 degrees because it's that top triangle we're using. 138. So this is where you're just going to use your recall button here to get that number in. And then MT is equal to 43.3138 ... times tan, 31 degrees, and that equals 26.0256 meters. Okay, so now finally we're going to figure out the height of the tall building, which is MB plus MT, and you're going to take this number, which is the 39, and you're going to add it to this 26.02 number. So 39 plus 26.0256, and that equals 65.0256 meters. So the taller building is approximately 65.0 meters tall. All right. Okay, so now we're going to look at this question. Now this question here, it's talking about a communications tower. So for this question, I actually built a little 3D model, okay, because so this is what we're looking at. Now that's a top view of the 3D model. All right, now if I show you the side view here, so do you see right here? This is where this triangle kind of comes about. So this tower is, it's kind of imagine that this is the corner of the room. So that corresponds to right here. If you look at the corner of a room, can you guys see what I did? Okay, so here's the corner of the room. This is the tower, and then there is this angle here. So Leaf is standing there. We'll call it L, and Tanis is standing here. We'll call it T. And we have the measures of this angle. So this angle is 70, which is this one right here. And this angle where Leaf is 50, so that's the one right there. So we have to figure out how far apart the two students are. So the far apart is right here. So how far are these two to each other? So do you see all these triangles in here? And how this kind of might not make sense unless you know what you're looking at. So imagine you're looking into a corner of a room, and that's the top, and you have an angle down and an angle down that way. So you have to figure out this side here, this line, you have to figure out BT, And you also have to figure out BL, and then you're going to use Pythagoras in order to find what LT is. Okay? So that's a procedure for that question. Okay, so let's go through that. So first we'll use tan T. So that's AB over TB. Tan 70. And then solving for TB, that's 35 over tan of 70. And that's equal to 12.7389. So don't round. And then we're going to use tan again to find this other triangle. So in LBA, which is here, here, and here, we're going to find this one now. So tan L equals AB over LB. So tan of 50 degrees equals 35 over LB. And then LB is equal to 35 over tan 50 degrees, solving for LB. And that we get 29.3684. Don't round this number. So now we're going to use this number and this number in Pythagoras, which these are both the shorter sides of a leg, and we have to find the hypotenuse. So LT is going to be the square root of 12.7389 squared plus 29.3684 squared, and LT equals 123 meters. So your final statement is the students are 32 meters apart. And really, we're going to say approximately. So here I could put in the word approximately because we rounded the numbers. Okay? So we rounded to the nearest whole number because it said round to the nearest meter right up here. All right. And there you go. There's all your homework. Enjoy.